Okay, so this may not look like it, but this is a challenging boss level kind of problem. Okay, because when you first do it or try to think about what to do, it's not clear. And once you do it, once you figure it out, it's still not easy. Okay, so um, I'll show you. Let's get started right now. First thing you want to do is just rewrite this in a way where we don't have to worry about that crazy exponent. So what I'm going to do is rewrite it like this. Keep the whole thing dx. I'm going to keep rewriting and simplifying this, okay, and they'll be clear on what to do. At this point, I should realize that this is not just a regular power rule kind of integration, because -2, there's no x at all up here in the numerator. Okay, so it's not just, you know, raising the power. Okay, and it's also not going to be inverse sine or one of the inverse trig integrals either, because of the cube in front. Okay, the inverse trig is only for when it's raised to the 1/2 or -1/2 power. Okay, yeah, so what we're going to do here, actually, it's going to be u substitution with trig. Okay, but this is definitely one of the more challenging ones, and you'll see why in a bit. All right, so I'm going to keep rewriting this. Bear with me. I'm going to mess up a few times along the way. So you might see me stop and go on the video. I'll try not to, of course. But here we go. I'm going to factor out the 4 first. So inside now I have 1 minus x squared over 4. The whole thing is cubed still. Okay. That's just square root 4. So I'm going to rewrite that as 2. Now at this point, oh, hold on a second, I almost forgot. That's actually not right either. Hold on 1 second. Write this. Square root only goes over for the 1 minus x squared over 4 parts. So the 2 is cubed. Okay, I can remove that as 1 over 8. And so what I have here, okay, the whole thing is cubed. Okay, so now I'm ready to do my u substitution. And the whole point of the u substitution is to not have to worry about the square root. Okay, so we want to choose the right u substitution where the square root goes away. And what you can do is let x squared over 4 equals sine squared u. Take the square root of both sides. Okay, so x over 2 is sine u. Okay. I'm gonna keep going with this. I'm gonna take the derivative of both sides. So that's 1/2 dx equals cosine u du. I'm gonna get dx by itself, multiply 2 on both sides. Dx equals 2 cosine u du. Okay. Not only that, remember, if you're going to get your expression, the entire integral expression in terms of du or u, then the limits and boundary need to be changed as well. So if I let, if I let x equals 0, okay, then that means 0 equals sine u. And the angle for when the value is 0 for sine is 0 radians or 0 degrees. We'll use radians though. And when we let x equal, was it 1? Then 1/2 equals sine u. And the only angles for that, one of the angles is pi over 6, 3rd degrees. Okay. So we have our new limits of integration. So we can do all the substitution later on. Okay, so let's have that ready. So now let's bring all this into the next step. we actually do the substitution. Okay, here we go. So look at this, 1/8 with new boundaries, it's from 0 to pi over 6, 1 over square root 1 minus, okay, remember x squared over 4 is now sine squared u. Dx is now equal to this whole thing. So 2 cosine u du. Okay. See the whole point. Almost forgot. The entire denominator is raised to the third power. See, the whole point is to rewrite this using the Pythagorean identity equations, right? Sine squared u plus cosine squared u equals 1. And now I can subtract sine squared over to get cosine squared u by itself. Okay, so I'm going to bring that in, and you'll see it gets a whole lot easier. Because now we don't have to worry about the square root. 2 cosine u, write the d on the outside like this, square root cosine squared u cubed. This is nice. Square root of cosine squared u just becomes cosine u. I'm going to also factor out the 2, multiply by the 1/8 to get 1/4 on the outside now. This is cosine cubed u now in the denominator, right? Because this becomes just cosine u raised to the third power, okay? And now you can also keep simplifying. Hopefully you can take this the rest of the way. So I know this almost looks unrecognizable to do as an integral, but if we were to write this, secant squared u becomes clear. So hopefully you guys know, you guys memorize derivative equations, but oops, you could directly take the integral of secant squared u, which will just be tangent u. Okay. And now the rest is just doing trig work, luckily. That just goes to 0. Tangent power of 6 is 1/√3. Or √3 over 3, √3 over 12. There you go. We did it. Give yourself a pat on the back. That was one of the worst ones I've seen. Well, it could get worse, but this is pretty bad too. Okay, so if you do something like this, yeah, you should be proud. Yeah, this is one of the tougher U substitution problems. Okay, good job, everyone.